Hey everybody, in this video we're going to talk about graphing a logarithmic function, basic. So when we're looking at these functions, in this instance f of x equals log base 1/2 of x, there's one thing to realize. With all of these log functions that don't have any horizontal shifts, it's not going left and right anywhere, okay? It's not going up and down anywhere. It is going to pass through the point 1, 0, and then our base and 1. And it's going to have a vertical asymptote at x equals 0. So for this problem, we can already say there's going to be a point at 1, 0, and then b, 1, or 1/2 and 1. So here and here. Now, this is what our function equals. Y equals log base 1/2 of x. If I wanted to put that in exponential form, I'd have a base of 1/2 raised to the y power equals x. So this is my little tip for you guys. Pick a y value. Usually we pick an x value, right? Pick a y value, and then we can figure out what x is going to be. So pick an output that we want to get. Let's say we want to see where the function is equal to 2. When I plug in 2 into my exponential form, I get 1/2 squared, which is 1 squared over 2 squared, which equals 1/4. Now, let's say, so my point will be at x is 1/4 and y is 2. Let's say I want to get output of -1. So exponential form, I would have 1/2 to the -1 power, which is 1 to the -1 over 2 to the -1, which is going to end up giving me 2. So if I put in an x value of 2 into my original equation, I will get an output of -1. So at 2, I'm at -1. And then, let's say I want to get an output of -2. I'm going to have to put in a 4 by similar reasoning over here, okay? Our negative exponents flip to either the numerator or the denominator. So I'll have a point at 4, -2. And don't forget, I have an asymptote here. So I'll put my asymptote in, I'll put some points in, and then we'll go ahead and graph. Now, that's one example. Let's do another. So let's go ahead and take a look at the graph of g of x equals 1 plus log base 3 of x. Okay, first, if we consider the function, I'm going to write this up here, y equals log base 3 of x. This is going to have points at 1, 0, and at b, which is 3, and 1. However, this 1 right here, what does that do? That shifts my y values up 1. So my point that was usually at 1, 0 is now going to be at 1, 1. And my point that was at 3, 1 is now going to be at 3, 2. So why did I do that? Well, that helped me see at least 2 points, 1, 1, and 3, 2. Now, I haven't moved left to right, so it's not going to affect my asymptote, so I still have an asymptote at x equals 0. So I'm going to go ahead and draw that in first, and then I'm going to draw my points. So I have a point at 1, 1, and then at 3, 2. Now it says to plot at least 2 points on the graph and then draw all asymptotes. So we've already done that. We could hit the graph button, but let's go through a few more points. Okay. how do I find an x-intercept? I plug in 0 for y. So I have 0 equals 1 plus log base 3 of x. That's nice, but in order to solve this for x, I need to subtract 1 on both sides. So I'm left with log base 3 of x equals -1. I don't have the tools to solve this yet, but what we can say is, wait, this is the same thing as saying 3, our base of 3, our exponent of -1 is equal to x. So what is x equal to? That's equal to 1/3, because the negative exponent flips it to the denominator. So when I plug in 0, I get 1/3. So when I plug in 0 for y, I get 1/3 for x. That's an important distinction. So at 1/3, I'm going to have my x-intercept. And then I can go ahead and fill that in like this. So there's another example.